We're on 6.6, solving exponential and logarithmic equations. This is video number 2. In the last video we solved exponentials, so now we're going to concentrate on solving logarithmic equations. And let's start doing that by going over the vocabulary of what a logarithmic equation is. And it's an equation that involves logarithms of variable expressions. So inside the logarithm is a variable. Okay? So core concept for that is our property of equality for logarithmic equations. Okay? If log base b of x equals log base b of y, so they have the same bases, the insides have to equal x, has to equal y. Okay? So it gives it to you algebraically and an example with numbers. So let's try using some of that. Okay, so now we're solving logarithmic equations. Okay, in number 5, we look, the logs are the same. Log base, they both have log base of e, so they're the natural log. And then they equal each other. So if they're both the same base, then the insides also have to be the same, okay? So I can set this up equal to 4x minus 7, that's the inside of this one. It has to equal the inside of the one on the other side of my equal sign. And then we just solve for x. So we need to move x to one side, so I'm going to subtract x to both sides. I get 3x minus 7 equals 5. Okay, then I still need to get x by itself, so I'm going to add 7 to both sides. I get 3x equals 12. And then to solve for x, we're going to divide by 3. So I get x equals 4. Alright. Now, number 6, I don't have logs on both sides. So we can still solve these without using that concept that we just used. X is inside my log. To get it out of the inside of the log, we have to write this as an exponential equation. Just like when we solved exponentials, to get the x out of the power, we had to write it as a log. So we're going just backwards, okay? So, remember, definition, when we talked about logarithms, the base, if I jump over the equal sign to this power, equals what's inside my log. So 5x minus 17. I can solve this problem. I don't have x within something that I can't just solve algebraically with what we've already learned. So 2 cubed is 8. Okay. I need to add the 17. I get 25 equals 5x. And I have to divide everything by 5 to get x by itself. So therefore, I get that x equals 5. Okay? Let's try this for 7 and 8. Okay. Now I have 2 logs on one side. They have the same base, but one's not on the other side of the equal sign, and I still have this 2. So I can't use the rule where if 2 logs equal each other, then their insides equal. And I can't just change this to an exponential right now. But I had a rule from 6.5 that talked about what this plus inside actually means. I can write this side as one log. Okay? So if my log has the same base, I'm going to still have that log. Inside my log, I'm going to have 2x, and it multiplies, that plus means I'm multiplying it by what's inside the other log. So it's going to be times x minus 5. And it still equals 2. I still have that 2 over there. So I just condensed this into one log. Okay, let's go ahead and simplify this inside a little bit. So log, let's see, I'm going to have 2x squared minus 10x equals 2. Excuse me. And we need to write this, we need to get the x out of the log, and to do that, we're going to write it as an exponential equation. Now, remember, if I don't have a base, my base is 10. So I have a base of 10, you jump over the equal sign, 2 is the power of what's inside my log, so 2x squared minus 10x. Now I just have a quadratic, and I can solve this. Okay, this quadratic is factorable, so I'm going to move everything to one side and simplify a little bit. I know that 10 squared is 100, so I'm going to subtract 100 to both sides. So this side became 0. Okay, and the other side is all of that. And this is factorable. So 0 is going to equal, and let's see, I can divide everything by 2. So that leaves me with x squared minus 5x minus 50. And let's see, this then factors into, let's see, we'll have x minus 10 times an x minus 5. Okay. So, for my answers, I get x equals 10 and x equals 5. But I need to check these problems out, okay? Oh, I'm sorry, wait, I knew I got something wrong. That has to equal that. That's a plus 5 there. Whew. I was like, something's wrong, so that means this is a negative. Okay. So I'm going to plug these in and see if they work. Now that's my common log, so it's pretty easy to type it in my calculator. Log of 2 times x, so we're going to try the 10 out first, plus log of 10 minus 5, because 10 was x, okay? This, whoops, and I put 0. 10 minus 5. Alright, and this needs to equal 2. Okay, so 10 worked, so that is definitely an answer. Let's try negative 5 out. Log base 2, or sorry, 2, natural log here, or common log, of 2 times negative 5, and my parentheses, plus the common log of negative 5 minus 5. And I get an error, okay? So it means it's a non-real answer, so I'm going to say that is not one of my solutions. It's an extraneous solution, and my solution is 10. Okay? So you do want to be careful that we always get our answers always work, okay? And I want to show you why that doesn't work. So if it was negative 5, if I just have log of 2 times negative 5, so that's this very first part, doesn't work because it's a log of a negative number, okay? That's what gave that away, that was not going to work. Also, log of negative 5 minus 5 doesn't work because it also would be a negative inside my log, okay? All right, let's solve number 8. So again, I have this plus inside, so I need to condense these to one log, so they're going to have a base of 4. And I'm going to have inside that an x plus 12. And then the plus means I'm multiplying it by x. So I'm just going to say times x. We'll just do it like that. And it still equals 3. Okay? Now, we could go ahead and distribute like we did over here, or we can hold off. I already see that I have x inside my log, so I want to get that out of there. I'm going to write it as an exponential equation. So my base is 4. Jump over the equal sign. I get a power of 3 equals what's inside my log, which, and I'm going to move the x to the front. So it's x times x plus 12. Okay? So I use the 4, the 3, and all of that. All right. So now I'm going to distribute. It just makes it so I don't have to write all of that over again inside the log. And I can go ahead and cube the 4. So 4 times 4 times 4 is 64. Distribute this x. I get x squared plus 12x. So again, I have a quadratic. We need to move the 64 to the other side, so we need to subtract it. So I get 0 equals x squared plus 12x minus 64. Okay, and this is factorable. So I'm going to have an x and an x. One has to be negative, one has to be positive to multiply to a negative. But they need to add up to 12x. So multiply to negative 64, add to 12x. The bigger number has to be positive for that 12 to be positive. So let's see, I get 16 and a negative 4. That multiplies to negative 64, adds up to 12. So that gives me my solutions that x equals, if that's a minus 4, it's going to equal a positive 4. And that's a plus 16, so it's going to equal a negative 16. And we need to try to make sure these work, okay? Right here, this one just has the x inside. I can see that when I plug in negative 16, that's going to be a log of a negative number, and it's not going to work. It's going to give me that error in my calculator again. Okay, so I can see that one right off the bat, okay? Let's go ahead and try the 4 just to double check that it works. Okay, so log base 4. Now again, if you have to, you can do change of base, which would be the log of your 4 here, so 4 plus 12 divided by log of 4. But I'm going to change my base because I can here. So 4 plus 12, get out of my parentheses, plus base 4, and then my x is 4. And that does equal 3. So x equals 4 does work. Okay? So now go on to your practice and do problems numbers 21, 24, 28, 34. I think I meant to write like 41 or 40, and then 42. Let's see, that number is 41. Sorry, that should have been a 41. And there you go. And then move on to the last video, video number 3.